Alright, g'day and welcome. Peace be unto you. Today we're going to look at the amazing Bismillah. Now, let me position this different to previous videos. We're not going to go straight into the analytics. What we're going to do is actually go and watch a video that has got about 100,000 views on the internet. It's about the opening verse of the Quran, the Bismillah, and obviously there's 114 Bismillahs in the Quran. 113 for each of the chapters. It's missing in one chapter, but then there's a double in another chapter. So basically there is 114 being divisible by 19. But let's go and watch this video, and then I'll get into the analytics of the opening verse of the Quran, which is in the name of Allah, all gracious, all merciful. Right, so I positioned this link in here. What we'll do is we'll switch over and watch the video, and I've got YouTube going in the background.
Let's begin with Basmallah, a first verse of the book which is found exactly 114 times in the Quran. Bismillah is the most frequent verse in the Quran. It sounds like this: Bismillahir-Rahmanir-Rahim. In the name of God, most gracious, most merciful. Bismillah is a perfect example to reveal the mathematical phenomena. Bismillah has 19 letters. It is easy to count even if you do not know Arabic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. These are numerical values of each letter. By adding their values together, we can determine the values of each word and total value of all words. Their value: 102, 66, 329, and 289. Total numerical value of all words: 786. Bismillah has 4 words, 19 letters. Total numerical value of Bismillah is 786. This 6-digit number is divisible by 19 without a remainder. Let's rewrite the sequence number of each word in Bismillah and after it number of letters in each word. This whole sequence is an 8-digit number divisible by 19. If we add the number of letters in each word to the number of letters in the next word, we will get a 10-digit number divisible by 19. If we add the numerical value of each word to the number of letters in this word, we will get a 15-digit number divisible by 19. If we add the numerical value of each word to the numerical value of the next word, we will get a 16-digit number divisible by 19. If we write the number of letters in the word, then the numerical value of each letter in this word separately, then the numerical value of each word, we will get a 48-digit number divisible by 19. If we write after the numerical value of each letter its sequence number in Bismillah from 1 to 19, we will get a 62-digit number divisible by 19. At first sight, it all seems as some sort of manipulation and trick. Skepticism in this case is quite appropriate and reflects a sound mind. It is possible to create patterns in words, even sentences, adjusting their values accordingly. This will take lots of time and mathematical skills. History knows of such examples. However, to do such task with a whole book, literary masterpiece, historical document, religious and philosophical scripture, ethical code, and judicial compendium is unreal. Colossal complexity of such task is unimaginable. Human intellect, especially in the 7th century, is simply not fit for such task. It would take supercomputer technologies to calculate data of such magnitude. It is not without reason that Quran challenges humanity to produce a book like this. Or do they say, he invented it? Say, Bring 10 invented chapters like it, and call it on whom you can besides God if you're truthful. So far, the challenge has not been accepted, and no one has been able to refute the mathematical miracle of the Quran. Will you dare?
Well, the graphics there, the animation was amazing. Obviously, there's a lot of claims made in it. I've paused the video halfway because then it gets onto a different topic on another mathematical phenomenon, a different kind. So I think we stick with the first verse, the Bismillah ar-Rahman ar-Rahim, which is in the name of God, all gracious, all merciful, or most gracious, most merciful. Two words, Rahman and Rahim. There's a lot of analysis and attempt at trying to translate it as best as we can, but at the moment, the best we can come up with is all gracious, all merciful. So that was basically a video. I think it's come out of Russia, and it is the animations are amazing. The graphics are phenomenal. So let's get into trying to understand and unpack. So some of the maths that I'm going to do is going to get quite heavy in the SQL. But before we get into it, let's unpack some of the claims that have been made. So he obviously presents this three-layered, almost like a hexagonal, almost like a beehive example, where the orange letters in here are basically the first. So you can see the arrows if you follow that. So B, S, M, Ba, Sin, Mim are the three letters for Basam, which is the first word. And the numbers here are the values, the Gematrical values. We'll come to Gematria in a bit, but it's a bit like Roman numerals. And back in the ancient days, and language was invented first, right? Then language was written, but numbers came in later. So before numbers were invented, letters were used for value, to assess values. For example, in Roman numerals, which some people who have studied Roman numerals will know that I, basically it's 1, 2, and 3, and then it becomes IV for 4, V for 5, and there's obviously 6 and C, and there's X and all that. So those letters were used to basically do numbers. Very similar convention in Hebrew and in Arabic as well. So over here in the first layer, the first word, the three letters are Ba, Sin, and Mim. So it has Ba, B has a value of 2, S, Sin has a value of 60, and Mim has a value of 40. And then it goes to the next word, which is Allah, which is Alif is 1, and there's 2 L's, Lam, and then there's a Ha. So that's the second word, and Ar-Rahman, which is then the third word, and then Ar-Rahim, which is the fourth word. So that's the blue color. So that's pretty much what he's trying to demonstrate on that. So 786, a lot of Muslims over the years would have known this number as 786 as a short form of Bismillah ar-Rahman ar-Rahim, and they probably never knew this is what Bismillah ar-Rahman ar-Rahim, what 786 actually meant. So if you look at the Gematria, if you add 2, 60, 40 for the first word, you get 102. 66 is Allah, ar-Rahman, then is 130, 28, 10, 10, that's 329, and ar-Rahim is 289. Add all of those, the weighted value, the Gematrical value of Bismillah ar-Rahman ar-Rahim is demonstrated as 786. When we get into SQL, I'll also show you another way to verify that. Now, if you go to Wikipedia and any other good website where you can look at it, it's called the Abjad numerals in Arabic. So you can see the value, the letter Alif and its value. So Alif, Ba, and then Jim. This is different to what is the Hijai order. This is the Abjadi order, which is where the weighted sequence is. And you can see from there to there, it's 1 to 9. Then from Ya to Sod, which is that letter there, which is a scene representation, goes from 10 to 90. Then Qaf is 100. I did a series on the letter Qaf in which we knew the Gematrical value was 100. And then it goes all the way down to the last one, Ghain, get to 1,000, a bit like a decimal system if you like, but that's Gematria. That's where the value comes from. And if you look on the internet, you'll find Hebrew as well. It has Gematria as well, because the Semitic languages are very close in their Gematria and their sounds as well. Okay, so the very first claim he makes is about using, and this is not just random, this is using, the interplay is always going to be about versus words, characters, right? And the geometrical value. So in this one, he's gone for the geometrical, he's gone for the number of words, which is 4, the number of characters 19, and the geometrical value as 786, right? So in the first verse, Bismillah ar-Rahman ar-Rahim, we'll show later on, is actually 19 characters as well. So when you concatenate those two in that pattern of words, characters, and geometrical value, you come up with a 6-digit number in this case, which when you divide by 19, you get a whole number. So this whole thing about 19 is a factor of these large numbers. So it's always wholly divisible. There's no decimal point here. It's basically if you multiply the two, you get that exactly. Now, if the geometrical value of Bismillah ar-Rahman ar-Rahim was out by 1, even 1, 785, for example, that whole sequence would fall apart. This is how intrinsic it really is, mathematically locked into this code. So that's the first sequence he presents, right? Then in the next one, I'm going to unpack this a little bit. He talks about this convention. It's color-coded as well. So the first set has 3 letters in it. The second set has 4 letters in it. The third set has 6 letters in it. And the fourth word has 6 letters in it. So that's n sort of length n concept. So, and that comes up to be an 8-digit number. So that's the number we get, 132434646, based on that convention as he presented. And it's color coded here, as you can see, to represent the first word, the second word, the third word, which is pink, and the last word, the third word is blue, and the last word is pink. And you can see it's 132434646. And again, he shows that when you divide this number, this sequence, by 19, again, you get a whole number, which is 36686. Okay, in this case, I think one of his divisions is not correct, and I will show you later on, but still is a whole number when we get into SQL and actually do it exactly letter by letter division. Over here is a slightly different phenomena. He's gone for a not so much a close, like a Fibonacci sequence, you know, it's adding numbers together as it's going. So literally, the first word 3, the second word was 4, but he adds the 3 onto that. The third word is 6, but he adds the 7 onto that to get the 13. The fourth word is also 6, and then you add 13 plus 6, you get 19. So that is a sort of like a cumulative run. And then again, an interplay between the number and the word in the number of characters in it, and then using an accumulative pattern. Again, same concept, divided by 19, it gets a whole number. So that's the 10-digit number that you end up with that sequence. Now, again, I'm just showing you this before we get into SQL, which is where we'll actually go to the Quran database in the background and actually unpack all of these patterns. If we can see if we can first of all formulate the pattern and then divide it by 19 to see if it's really true. Over here now it starts to get a little bit more complex. So 15-digit numbers, again, it says, okay, the first word, what's its geometrical value? 105, right? And then puts a second word, what's its geometrical value? In this case, he also tags on the value of the previous one, right? The 66 is the value of this one, and he adds in the value of the characters that are in there. So 329 we know is the value before. He adds that in and also adds the number of characters. So it's got this n value, n number of chars, and then adds the value back on and keeps going. So it comes up with this sequence. Again, it's an interplay on the word's position, number of characters, the geometrical value, and then also incrementally adding on the number of characters in each one of them, which is the num chars over here that I've done. So again, it come up with a 15-digit number. Amazingly, divided by 19 is you get a whole number again. I mean, you get this wrong by one number, and the division by 19 will fall. You'll get a fractional number. You know, a decimal point xxx will happen. But it's quite amazing that even this pattern. And then it gets even a little bit more complex. Now in this one, you can see that the 26040 is basically the geometrical value of the first number. It was 102. And then he takes the second geometrical value, the second number, takes along, but also then increments a little bit like the Fibonacci sequence or a cumulative addition. It takes 102 from the previous sequence, adds it on, and does the same thing with the third one. It takes the geometrical sequence of the number by itself, of the third lot, the pink, right? Beg your pardon, the blue. And then he adds on the geometrical values of the previous two sequences, which was 102 and 66, right? Over here. And in the last one, obviously, 130, 208, 10, 10, he adds it all, you get 289. Then he adds in the previous sequences, the 329 for the blue, and then the 66 for the green, which is the Allah, and the Basam, he adds it back on as the 102. And then he gets this, again, an amazingly long number, 16 digits. At some point in time, your calculator also fails because you can only put so many characters, so many digits in your calculator. Even my SQL, when I was doing this, at some point in time, couldn't handle the, even if I used a big int, which is a big integer value, couldn't do it. But I'll show you a way that we can, we don't have to get a supercomputer or a mainframe to try and do large integer, but this is okay. This does divide on a calculator, so 19 times, again, a whole number. So amazingly, the 19 still holds. Now the next sequence he does is a 48-digit number. Now this is phenomenally long, right? But you can see what he's done there is basically the number of characters in the word, which is 3 in the first one. Then he has got the geometrical value, 102. And then for each of the characters, it puts the geometrical value of the characters in there, 22, 60, and 40. And just keeps repeating that pattern. You end up with a huge big number based on this pattern. And the number of characters in the word, the geometrical value total, then the geometrical value of each character. And then he sequences it all up. And when you divide that sequence by 19, it's showing that you get a whole number. Now this is going to be very difficult to divide on a calculator. 48 digits, that's huge, right? Now, to make things even more complex, he's gone one level more and come up with a 62-digit number. Now again, this one is a little bit interesting in the sense that it's the geometrical value and the index of each character. So for example, if we start with Bismillah, the 2, the ba, has a geometrical value of 2. And then he puts the index, which is 1. Then the next character, which is 60, and its position is 2. Then 40, obviously 3, and so forth, all the way down to the 19th character, right? Which is right at the end here. At the end of the last character is 40. Because 40th, after the 40th value, the position is 19. Being 19 characters in this sequence here. Again, a massively big number, but it is divisible by 19. Right, so I guess what we'll do is try and summarize all of those claims into a single table. So this is what I've come up with. These are the 9 claims in each of these. As we look through, the Bismillah is the opening verse and has 19 letters. There's a claim on that. The most frequent verse, Bismillah is the most frequent in the Quran. It's got 114, obviously, mentions in the Quran, 19 times 6. So the value of the Gematrica, the first pattern he did, the second pattern, the 8-digit number, then the 10-digit number. Oops, let's go back up. Then he came up with that 15-digit number, so the 16-digit number, then the 48 and the 62. And I've shown here that obviously one thing that is consistent in all of this is 19 is playing a part in every number that he has generated. All right, so that is the task ahead for us. What we'll do is we will switch over to SQL. And if you haven't seen my SQL database setup video, please go and watch video 000, which is a DB setup video on my channel, which shows you how the database ERD, the data is modeled, and how I've created and shown you in detail the database that the rest of the analysis is done on. Okay, thank you. Okay, so let's switch over to SQL, which is where I will do all my verification. Alright, so this is my SQL setup here. I'm just showing you my database diagram. So you're just a refresher quickly. I have a chapters table, which contains basically information about the 114 chapters. Some attributes of each of the chapters is over there. Q verse is my main table in which all the verses from verse 1 of chapter 1 all the way to the last 114th chapter and the last verse in that. So those there's a relationship between those, and then there's obviously a couple of word tables, which is basically an aggregate of all the words used and various information about it. Similarly, I have a characters sequence, basically a character table, which is the Arabic characters and their English representation, and there's also two aggregate tables that I've got for every character, every alphabet used in the Quran. It's various attributes, its positioning information, and the Revelation city, basically information about which city the chapter was revealed in. Anyway, for the example in this particular query, in this analysis, let's go and open all these SQL files that I have pre-prepared. While that's opening up, you can see that there's a number of SQL that I have prepared over here. So first thing we'll do is have a look at the first few claims. Now, around the Bismillah, which is the first verse of the first chapter. Okay. Now, one of the claims that was made was about that it is the most common verse in the Quran. So I've written this SQL here. I'm going to talk you through this. You don't have to know SQL. Basically, I'm just doing a distinct, which means find the unique occurrence of Arabic verses, entire verses, and count them up, and then present it to me in a descending order, so most from highest to lowest. So I'll run that for you, and you will see that it will return a set, and you can see Bismillahir Rahmanir Rahim occurs 113 times. Obviously there is more Bismillah, there's one more, but it's embedded inside another verse. So by itself it's one short here. That's another video I'll do around the missing Bismillah. But that you can see is the most voluminous, the most number of times any verse occurs is this the subject of today's video. It is 113 in that particular occurrence. I'm going to do it another way so you can see. I'm going to use the English transliteration this time, so you can see that it's written this way: Bismillah ar-Rahman ar-Rahim. Again, same number, so you don't expect to see anything different. It is the most frequent, which is one of the claims the gentleman made in the other video. Now, the number of Bismillahs, I've got a flag in my verses table. On any verse of all the many 6,000 plus verses in the Quran, there's a flag on it. It is a Bismillah verse, which means if it contains Bismillah in it, then that's the query basically. So if I run it, you'll see what I mean. It actually, if you go to the messages tab, this you'll see 114. So there's actually 114 rows in the Quran. 114 obviously is divisible by 19, which is again the numerology of all my videos in this series. So 114 times Bismillah occurs, and you can see over here it's presented from chapter 1, 2, 3, 4. You can see in 9 it's missing, which is a known phenomenon. Chapter 9 doesn't have a Bismillah. However, you scroll down over here, there'll be a chapter 27 in which occurs twice. Once completely by itself as the first verse, but then again it is embedded inside another. This is the missing Bismillah concept. Anyway, the answer was that we get 114 Bismillahs in the Quran, and it is divisible by 19. One of the claims that the gentleman made. The other thing was around the Gematrical value. Now, if I just get verse number 1 from chapter 1, which is the first verse in the Quran, and just present the information about that from the verse table, you can see verse 1, chapter 1, Bismillah ar-Rahman ar-Rahim. That's the English transliteration, the Basm, in the name of God, in the name of Allah, most gracious, most merciful, or all gracious, all merciful. That's Abdullah Yusuf Ali's translation I'm using. It is the Bismillah verse. And you can see some attributes here that are important. The Gematrical value, which is what he showed, that the Gematria of Bismillah ar-Rahman ar-Rahim is 786. I've got the same value. Character count is 19, word count is 4. So 4, 19, and 76. These three numbers, just remember them because the sequence is used around that as well. Now, just to show you that that's just not an attribute that I've just concocted up, I've got another table called the char count table. And what I'm going to do in that is I'll go to verse number 1 of chapter number 1 and say, can you count all of those characters in there? Obviously all the ones that are more than once, because it stores zeros as zero characters as well. It does all the 1 to 28 characters, but if it's not there, it puts a 0. So I'm just interested in the ones that are greater than or equal to 1. So let's do a query of that, and you can see we get these values. So character ID 1, which is alif, occurs 3 times in that. So these are all the Gematrical values. And if I were to sum that up, just to show you, if I sum that Gematrical value into a field called verse 1 gem total, which is basically going to sum all of these values here, which is exactly the same query from before, but now we've got a sum going on. So if I sum that up, this is where the 786 will appear. There you go. 786 is the Gematrical value. I'm summing up all the Gematrical value of all the characters in the first verse of the first chapter, chapter number 1, verse number 1. Okay, we got 786. Now, the characters in Bismillah, just another query just to show you. So we did this time using the count table. We already saw it on the verse record that it is 19 characters, but I've also done another way just to show to you. And I've done both the Arabic count and obviously the English equivalent. And yes, it is exactly 19. Now let's run another query. So if we run this query here, and I'll explain it to you. Okay, so you can see that the Bismillah, Basmallah ar-Rahman ar-Rahim, each of these have individual values. And if I take 102, 66, 329, and 289, like that, you can see I'm summing exactly all of this just to show you. That would also be 786. The Bismillah actually is 786 in Gematria. Okay. So after the demo, I'm going to use a lot of user-defined functions to prove all those large sequences that the gentleman produced. But we'll come back to it because I don't want to bore you to death. Just that there is logic written behind the scenes which does all the sequencing. Okay, so the very first, so we've covered a few things there. We've covered that the 786 is the Gematria of Bismillah ar-Rahman ar-Rahim. We covered that it has 19 characters. We covered it has 4 words. We covered that it has a Gematria of 786. So, and then it occurs, Bismillah occurs in the Quran 114 times. It's also the most voluminous, the most number of occurrence of any other any verse in the Quran by itself. So in the first example that he did, he presented a sequence 419 and 786, sorry. And that's as we know, it's made up of the number of words in Bismillah, the number of characters, which is 19, and the Gematrical value. So I've written a sequence here just to explain what how the 419 and 786 comes. Now the claim is very simple. When you put 419, 786 like that in a concatenated format divided by 19, you get a whole number, right? Now, in my database, I'm going to do a select on the word count, which is exactly what we're on. The first character is word count, then the character count, then the Gematrical value, and we're going to concatenate it and put it into a field called number check. Then we're going to cast that concatenation into an integer value and divide it by 19.0 to show that whether it is divisible by 19 or not. And we're going to do that on only the first verse and chapter number 1, right? So if we run that now, we should get that phenomenon where 419,786 concatenated appears like that, divided by 19. You can see it's not returning any 0.234 or anything like that. It's 0, so it's a whole number divide. In SQL, you have to divide by 19.0. If I did 19, you get a whole number anyway. It'll chop off the decimal bits, but just to prove the point, I had to divide by 19, and you can see you return a whole number. So that is one of the claims straight away. Remember that pattern 419,786? It is totally divisible by, exactly divisible by 19. And how many digits? Just to run that, you can see that 419,786 was 6 digits. So the numbers start to go up, as you saw in the sequence in the video. It became 10 digits, then 15, 16, and then up all the way to 62. So that was the very first one done and dusted, right? We proved that the sequence where the number of words or number of characters and the Gematria, concatenate them, it is come up to this number 419,786, and divide by 19, exactly a whole number. All right, moving along to the second one. So the sequence here was 132434646, and it's basically based on the first character, the length of the first word, the length of the first word, and that sequence, right? So he showed in his video that we come up with that number. If you divide by 19, you get a whole number. Okay, in his video, he had this number 36686, which was whole, but that was probably an error, I think, on his part. But again, the point is still it's a whole number division. Okay, let's get that sequence. So in my database, I've already got this sequence based on this idea of the word, its length, next word, next which is 2, then the number of characters and stuff like that. So I have already got in my database a field called that, but I will, just to show you, I'll also run a user-defined function so that you're not thinking that I'm just making a number up. So if we take that number and I'll run it here, you can see that we do get that sequence, and it is divisible completely by a whole number. So 69734. Now, what I wanted to show you is I've also got these user-defined functions, which I'll show you right at the end. So this function, which is like a backend logical function, which does all that number joining and crunching to formulate the pattern. Right, so if I run that function and I run the Arabic version of it on verse 1, chapter 1, as you can see, I'm limiting it here. And let's run that. You can see again, I get the same sequence, and I've got the division by 19 as a whole number. Now let's do the same thing on the English equivalent. Again, we get the same sequence. And how long is this thing? Let's run that as well. This time it is only going to be 8 digits. So this, if I run the whole thing all together, and see what's happening is the pattern we got was that pattern there. The first verse, 3 letters. First word 3 letters. Second word 4 letters. Third word 6 letters. Fourth word 6 letters, and that's that sequence there that I have generated, and you can see that it is divisible by 19 exactly, and the number of digits we get is 8 of the number that was generated. Okay, so let's go to the next one. We're up to the next sequence now, so we're going to do this one, which is this time a little bit more complex in the sense that it's doing a first number. First, the 1 stands for the first word, and it has 3 letters. Then the second one stands for 2, second word, but it adds the 4 and the previous 3. So it's then it does a 13 plus 6 for the next one plus 7. So it does a cumulative. So that's sort of formulated in this maths here. That's the sequence it produces over here. And again, it's divisible by 19. So find the first character, add its number of words, and then keep accumulating it. So I've already done a sequence in my database. There's a sequence 6, which does that word, number, and then character plus plus. So if I run that, you can see that we get that sequence. You divide by 19, you get exactly a whole number, which is exactly what he showed in his demo. Now, in terms of a user-defined function, just to show you that this function does go ahead and it does this sequencing calculation. I'm going to call that in the Arabic version of that. You can see again we get the same sequence and it is divisible by 19 exactly by that. We're going to do the same thing in an English user-defined function. The English transliteration, again we get the same thing. And how big is this number? You can see now we're getting into 10-digit space. I'm going to run the whole thing all over again. You can see the results here that for the using the database field that I've got the same sequence using the user-defined function in Arabic and then English, and you can see that it was it's a 10-digit number and it's divisible by 19 exactly 6985860 times. Okay, so that's that sequence done. That was that 10-digit sequence that he produced. Again, there's a method to his madness to that sequence that is produced. Now the 15-digit numbers, now it's starting to get a little bit more heavy. The pattern is a little bit around, you know, the n and the value of the n character, then the number of chars, and then it goes on to the next one and sums this up. So this is the pattern he gets. I should put that up here. So this is now into the big 15 digits. So if I already have a sequence 3 in my database, which I pre-calculated, I'll show it to you. So we run that, you can see that that's the pattern. If you divide by 19, which is what I've done here, I'm going into big int because these numbers are getting too large to fit into an integer. At some point in time, SQL will also bomb out, so we'll have to use a different method. And I'll show you how we can achieve that when the numbers are getting phenomenally large, like 48 bits and 48 digits and 62 digits. So that's, again, we're still doing chapter 1, verse 1, right? That's where the Bismillah is. And now this time I'm using a different user-defined function, which does this mixed geometrical sequence value plus the number of character calculation. Same thing, it basically does that pattern. I'm going to run the Arabic version of it. You can see that it comes up with a pattern. It is wholly divisible by 19. And then we run the equivalent in English. Then get Gematrical mixed sequence user-defined function. And again, we get the same thing. How big are these numbers now? They're getting pretty large. So the main number is 15 digits. Its divisor, what we divide by 19, it's a 13-digit number. So let's run this whole thing again, just so that you can see everything in the one place. So you can see that. Always pause my video and go watch the other video and see that these numbers are exactly the same. So the number sequence this time is this number here, and it is divisible by 15, and a 15-digit number which is divisible by that, exactly that number, and it's a 13-digit number now. So that's that claim done around that sequence of the number, the value, then the number of characters, and that sequencing. So moving along to much larger numbers, the 16-digit number he showed us is based on a pattern where it's using a sort of like a Fibonacci kind of or a cumulative value summation again, but these numbers are getting phenomenally large now at 16 digits. So I have a sequence I've already pre-populated in my verse table against that chapter number 1 verse 1. So let's just run it against that pattern. And okay, once again, wholly divisible by 19. Now I've got these user-defined functions. Just to repeat the pattern, same thing, we get same number, we get a wholly divisible, and then we're going to run it in English, and you can see that we get the same whole number again. And then last but not least, I'm just going to show how many digits was this. We're into the 16-digit space. Run the whole thing all together, and you can see that the pattern we got, this pattern is what he got, and it was divisible by 19 exactly that many times. So by a whole number again. So this was true again from his presentation. So this was in the 16-digit value that he produced. Now we're getting heavier into the 48 digits. So this sequence was really interesting. I liked it because it was about the number of characters in the word, then the geometrical value, followed by the geometrical value of each character. You know, and it's phenomenally large number. Now we're going to run into a problem here because this number may not be able to be calculated on a calculator, but let's see. So I've already got that sequence. I call it sequence 1 in my database. I'll run it. I pre-produce against every verse this thing. So here's that massively large number that we're talking about. Now, if I now use my user-defined function that my system works out on the pattern that was presented, you can see on the Arabic I get the same thing as I would get in the English version of it. Same sequence. Now I'm not doing a division, and the reason for it I can show you. If I take and put the division back in here, division by 19, it will actually crash because arithmetic overflow error. So I'm getting pretty large numbers. So what we will do is I'll show you a website instead of going to a super frame or supercomputer to try and do this 48-digit division. There's a website where we'll do this division. So let's just run all of these. I'll just not do the division in my SQL, and you can see that the numbers down here are exactly the same. We're producing these really large numbers, both for the Arabic version and the English equivalent transliteration. It is a 48-digit number. This is what the answer was. You actually have a 47-digit number that is divided by it. But anyway, let's copy this. I'm going to copy this. I'm going to go over to this website over here. I think it's a French website, www.decode.fr, big number division. So in here, if I just show you an example, if I have 38 and I'm always dividing by 19, so that's my divider, that's my number, I should get 2 over here. So over here is where the results are on the left. So if I divide that, you can see 2. If I just for a minute make 38 39, now you should see a whole number. The result you can see is 2.05. Now let me paste in the number I just got from our big number that we just had. You can see it right there, right? Pardon the ads that are playing here. We're dividing that number by 19, divide it. The results you can see is this number here, which I'll take back to SQL and show you that that is exactly this number here, right? And you can see, I'll just copy, paste it in here, and you can see that it is 47 digits. The big number, the 48-digit number was that much, divided by 19, you get a 47-digit number. And as you see, there's no point anything here, so it's wholly and fully divisible by 19. Okay, so that's that 48-digit number pattern done. Let's go over to the other massive number, the 62-digit number that he produced. Basically what that is the geometrical value and then the position of each of the characters. So for example, the Basmallah B had a geometrical value of 2. Then it says, okay, the Basam has a position of 1. The B had a position of 1. The next was the Sin. Sin has a geometrical value of 60. Its position is 2. So that's the pattern it's trying to do. It's a Gematria and the position, Gematria position, and it just goes through all characters. There are 19 characters, so the last one will be 19. So that's that massive 62-digit number that he formulates. Now I have got a sequence in my database for that, which I've pre-populated. I'll run that on that, and you can see, once again, I haven't divided here by 19, because if I did, let me just uncomment that and run it, it'll crash because it's too big for division to happen. They got arithmetic overflow, so I'm just going to comment that out again and just get the number out, right? Oops, query. So if I just run this entire thing, the Arabic version of it, the English version of it, and the numbers down the bottom, let's run the whole thing to save us time. You can see these massive numbers are appearing, not even enough to fit. So that number is a sequence that comes up if you do the Gematria followed by the character position and all that, right? Now, this number is the value that he showed in his demo. So we're just going to take it over here and put it in here. I'm just for a second just going to change the last digit and make it 8 so you can see. If I divide it, it won't come up with a whole number. See, it's got 94. I'll actually paste in what I actually have and divide it by 19. You can see it'll end up with a whole number. Get a whole number right there. Quite amazing. It's like mind-boggling. When I saw this thing unravel, it was like, oh my god, how amazing it is. And just the sequence. If you love numbers, and this is like, I think it was Galileo Galilei says that God was communicating with humankind using the language of maths, and this was sort of like unraveling that for me a little bit. So you can see that that's the number that we get. So if I run it all over again, we actually, what have I done here? Okay. Okay. So this is the pattern we get, that large 62-bit number, both in my Arabic version and my English version. When I say English version, the transliterated form of Bismillah ar-Rahman ar-Rahim, and it's 62 digits long. Its divisor by 19, it's a 61-digit number. It's wholly and fully divisible by 19. So that's all the phenomenon done. Now, I did have one bonus find, which they didn't cover, and I thought I'd share that with you. So if you take this pattern where the nth word and the Gematria are concatenated, so by that, if I just run, I've already got that sequence in my database. If I run that, you get this sequence. You can see the first word, its Gematria is 102. Second word, its Gematria is 666. The third word is 329. The fourth word is 289. Not sure if he presented this, but I didn't remember if he did it. I couldn't work that pattern out. So I saw that this is another of those sequences that actually, if I run all of this, you can see that this sequence also generates a number which is 15 digits long. It's also divisible by 19. So in this, what is this sequence? It's the nth word and its geometrical value of that that word, right? So the word 1, Gematria 102, word 2, Gematria 66, word 3, Gematria 329, word 4, Gematria 289, and that sequence is also divisible by 19 exactly by that. So that is a bonus finding that I did. So that takes care of all the mathematics, like everything that we saw in that segment of his video, 100% passes. There was one mathematical calculation, I think just a number that he presented was incorrect, but it was still a whole number. So in terms of the, unless it's my error, but I have not seen any of those sequences not being divisible by 19 as a whole. So the number 19 for the Bismillah, amazingly, not if one count is out, the whole sequence falls apart. So mind-boggling. And apart from the fact that his animation, as you can imagine, was amazing, spent a lot of time putting all that funky graphics and animation together. All right, so we basically went through that all the 9 claims and literally checked through each one of them. 100%, every one of them, all 9 claims were absolutely spot on. They're very large numbers here that we're playing with. Like I said, you can't even divide them on a calculator or in Excel or anything. You have to go to the website, or if you have access to a super computer somewhere, you can divide numbers beyond, I think, anything that goes beyond 24 digits on some extended calculators gets a little bit tricky. But we found a way around that by using that website where the French website where there's large number division happening. Thank God for that. And now also that other sequence, that's the bonus I found with using the nth word and the value of that word sequence. You get this 15-digit number, which is also divisible by 19. Amazing. That's why I call it, this is the Bismillah ar-Rahman ar-Rahim. In the name of God, most gracious, most merciful, occurs in the Quran 114 times, divisible by 19 itself. It is amazing that these sequences that are interlaced with each other, where they use the characters, words, gematria, all of those really phenomenal that it actually is 19 based. And imagine 7th century, they're expecting a human to be able to encode all of that. So the words of Galileo comes to mind, that if God was communicating with us, the language of communication would be numbers. There's patterns in the world. Everything E is equal to mc squared. The maths we're discovering is not a discovery, it's we're learning. Basically, it's already there. That's my take on it. Now, what's next? I have been meaning to do basically the fact that we've demonstrated a number of videos now, with 19 just coming up and bubbling up as one of the strong encoders in the Quran. But why 19? I still meant to do that video. Hopefully I'll do that next. So if you haven't understood some of the SQL aspects of it, you probably need to go watch my SQL setup video 000, and it'll show you how I've done my ERD modeling and how I've imported data and all that really deep dive into the SQL setup. Now, once again, I'm wrapping this up now. Thank you very much. If you like what I've done, I really appreciate if you could subscribe, give it a like. Any comments, any positive, negative comments, as long as it's respectful and considerate, happy to take that on board. My channel is I Reason, Therefore I Am. Good night and peace be unto you.